This image taken by the Hubble Space Telescope is called a Hubble Ultra Deep Field image. It required a week-long exposure to collect enough light to make the image. Except for a few foreground stars, which show cross-like flares to them, each object in this image is a galaxy. There are about 10,000 galaxies in this image. The cross-like patterns are from what is called pixel saturation. This occurs because of how bright those nearby stars appear compared to the faint distant galaxies. Note how galaxies vary in color and morphology, or shape. Edwin Hubble noticed this too, and he created a scheme for galaxy classification that is still in use today. Spiral galaxies are disc-shaped, with or without spiral arms, and a central bulge. They are populated with tens to hundreds of billions of population 1 and population 2 stars. Barred spirals are similar to spirals in every way except that they have an elongated central bulge that can appear like a bar structure across its middle. These bars may be the result of recent galaxy interactions or mergers and may not be persistent features of these galaxies. Elliptical galaxies have an ellipsoidal structure. In fact, it will often be useful to think of them as a central bulge without any disk structure. They are devoid of star formation and are composed only of population 2 stars. Dwarf ellipticals can consist of millions of stars, whereas giant ellipticals can contain hundreds of billions to trillions of stars. Shown is the Hubble tuning fork diagram. Above right are the spiral galaxies. The A, B and C letters are given based on how tightly wound any spiral arms are and how large the central bulge is. SA galaxies have large central bulges and tightly wound spiral arms. SC galaxies have small central bulges and loosely wound spiral arms. The same scheme goes for barred spirals below, except an uppercase B is added to indicate the galaxy has a bar. On the left are ellipticals. The E is for elliptical and the number is a measure of how elongated the galaxy is. E0 galaxies are more basketball-shaped and E7 galaxies are more cigar-shaped. If a galaxy doesn't seem to have any definite morphology, it is categorized as an irregular galaxy. Irregular galaxies are disorganized galaxies that often look like train wrecks. They consist of millions to billions of population 1 stars and have high star formation rates. Large populations of small primordial irregular galaxies are seen at large look-back times and are believed to be early stages of galaxy evolution. Many nearby irregular galaxies are often the result of mergers or galaxy interactions. Other nearby irregulars may be late bloomers that have only recently begun to take shape and form stars. Going back to the Hubble tuning fork, the irregular galaxies have been placed on the far right. By doing this, trends in galaxy behavior can be more easily pointed out. Going from irregular galaxies, through spiral galaxies, including barred spirals, to elliptical galaxies, one finds that the bulge and halo masses are larger. Irregulars basically have no central bulge and ellipticals can be thought of as entirely central bulge. Another trend is that the galaxies are found in larger groupings. Irregular galaxies are often found isolated. Spiral galaxies are found in what are called groups, consisting of 30 to 50 galaxies in a region a few megaparsecs in diameter. Elliptical galaxies are found in clusters, which are about 10 times larger than groups in size and population. Another trend is that the rate of star formation decreases. In fact, star formation ceases somewhere between SB and SA spirals. Possible causes for these trends will be discussed later in the chapter on galaxy evolution.